Thanks for coming, especially after lunch. It's always difficult. So if you fall asleep, I won't feel offended, so feel free to just fall asleep on the beautiful couch. My name is David Gonzalez. I'm a software engineer. I work for a company called Mixtiles. And today we're going to talk about some experiments that we did with Kotlin Multiplatform. Does anyone have any experience with Kotlin Multiplatform? No one? Yeah, sweet. You don't count. It's okay. Perfect. The idea is we saw as an opportunity to learn new things and also to understand if there was an opportunity for the business to get some improvements in how we work together between the iOS and the Android teams. So what we're going to see today is a very honest explanation of what we saw, how it worked, and what didn't work. And basically, so you can have an idea that if you want to try it for yourself, hopefully this is a good start for you to take a look at it. But before, I guess, with every cross-platform framework, the questions are always the same. It's like, should we trust this? Because I've seen this before. I've seen several frameworks that would say, I'm going to be the next big thing is a new solution where you can have one code base that runs everywhere. It's going to just, for sure, only just be one single code base. It's going to be very simple. Everyone's going to love it. It's going to be super cheap for the business, so the management is very happy with that solution. The developers are going to be very happy as well, because everything is going to work. You will never have to refactor anything. And this is sort of a different approach. Basically, the idea with Kotlin Multiplatform is to take advantage of a language that's getting to a very mature position. And it's also the fact that you can have your own parts written in Kotlin with the multi-platform features that we're going to see later, but you still can develop your native Android and iOS app in Kotlin, Java, Objective-C, or Swift, or even with other cross-platform frameworks, and it's not going to interact with it. You can always use the best of both worlds. So it's a kind of more honest and very simple approach where we just want to make things happy and make things easy and all the developers happy using it. Truth is, it's still experimental, so as of Kotlin 1.2, 1.3, everything that you're going to see today can and probably will change, but it is in a state that these things are in production, what you're going to see is in production and it works, and there's other companies that have done way more things than we have, and you see some examples as well, and it is working. So it's if you have to take a gamble, it's a good thing to experiment, and I think I would recommend it. But the truth is, start is painful. It's not simple to just start working on it. It's not one of those things that you just drop in and everything works easily. It takes time to make it work for everybody, and especially because it's a different paradigm. Because if you're an iOS developer and they say to you now, right, from now on, all the business logic is going to be in Kotlin. Well, maybe you're not happy with that. No, I already learned Swift. Why do I have to learn a new platform, a new language, to get things done? So it's not an easy thing to just get all your team on board, but it's very interesting. And the basic point is that Kotlin, it doesn't limit you to always use features that only exist in the multi-platform world. You can also have it the best of your native platforms, and we're going to show how you can interact with it. The basis of the whole system is this expect and actual mechanism. This basically means that you can define things in the multi-platform world that you expect, and then your native implementation, whether it's iOS, Android, or any other frameworks that are supported by the multi-platform projects, you can just provide those specific on the language basis. So let's see how that looks. We have a simple function, and it's to write a log message. And notice the simple keyword expect. That means that it's something that you're defining. The implementation of this function is not in this multi-platform module. Just expect anyone who's trying to consume this to actually implement and show the actual implementation. So imagine we have this log, and you want to just call this function to print a debug message. In your actual implementation, you have this actual keyword, the keyword that is in front of the function, and this is saying, whenever in my multi-platform project I'm calling this write log function, this is the actual implementation I want to execute in the platform that I'm targeting. you can go a bit deeper, and basically that's the same thing, right? Different platforms can have different implementations, and it doesn't have to be just one. You can have multiple implementations for all the different platforms. It's also very interesting because the IDE helps you to understand all this. So if you have an expect, this is just a simple variable, and you have not defined this variable in all the other modules where you're expecting to have it, the IDE will tell you, hey, this is missing. This is a compiler error, so you need to fix this. And you can just use the auto-completion from the IDE that will tell you, well, you can have this. This is a library with iOS and Android. So here it was telling you, well, you haven't implemented this actual, you don't have defined the actual implementation of this variable in the Android module, in the iOS module. And then you can just simply use the IDE auto-completion, and it will create that for you. So the IDE is very mature in the sense that it's very simple for you to start using it. If you have any questions, in the meantime, just raise your hands. It doesn't have to be, it's easier if you do it that way. Let's see, there's a very important definition that we have to, there's a very important distinction that we need to define, and that is native versus multi-platform. And it all comes from the plugin that you use when you implement it. Multi-platform is something that only works for multi-platform projects. And that means that you have a project that uses, say, web, iOS, and Android. Native is for a native project. That would be something that only uses the native platform. And that is not native on the mobile sort of things that we understand. It's native as is C++ and very low level. There's a very difference between multi-platform and native. Let's see. Something which is very interesting as well. You can have these platform-specific decorations or that you can define. And let's say an example. You expect a class called atomic reference. And what you can do is you can say, well, I can define a type alias in Kotlin that is going to say that whenever I have reference on the atomic reference class, when I'm using this module, then I really want to use the atomic reference class from Java. That means that you can have type aliases between one class that you define, and then the actual implementation or the actual construction of the class in another module. Let's see. Let's start with let's have a visual example. So you're going to see 3 different steps to how you can use multi-platform as a library. And we're going to go through all the issues that we've had and what is the pitfalls and what are the pros and cons of each one of them. The first one is creating a library, right? You go to the IDE, you want to create a new library, and it's not very clear what should you use. Should I use a multi-platform library, a mobile shared library? And if you don't know or you haven't properly done before, I'm going to choose, for example, a multi-platform library. And I will create a project with you that has an Android folder and has a source folder, and inside of these things have different implementations, and you want to compile it, and then this happens. This is just before just opening, creating a new project, and doing nothing else. This is the first thing that you would see. It's going to start spitting out errors that you don't understand where they're coming from. So in the end, it's a building blocks approach, so you have to be very pragmatic about it, very simple, and start with various steps. So let's see. It's important to define how the structure of this project should look. So we have a root folder, which is what our library is going to use, is going to be. And then we have 3 different modules in the same project. And I say modules as in IntelliJ modules. We have an Android app module, which is all the code that the Android library will use. We have an iOS module, and we also have a shared code. And this is the names that you want to define, right? But the idea is everything we live in the shared code is going to be all the expect definitions, and everything that lives in the Android or the iOS are going to be the actual implementation of those definitions. So let's see. Inside the Android module is a normal Android project that you might be used to. It has the same structure and the same files. Everything is very familiar. Inside the iOS, you also have a very familiar structure. It's the Xcode project and all your frameworks and all your tests. That's the same structure that you would have. And then the shared codes, that's when it gets a bit more interesting. You have a source folder that will have 2 folders per implementation. So let's see, what does that mean? You have the Android main and the Android test, where all your Android main, it will be the source code for whatever you want to use in the Android module. your test folder, and all the same things for the iOS and for the common. So bear with me because it's a bit complicated. If you have to kind of define all different dependencies, this is the nice thing that the Gradle file will give us for the library. You can have different sources, and you define what are the dependencies for each one of those sources. So you can have platform-specific libraries for your common module, for your Android or iOS module, and more generic ones for common. So in this case, we have a common standard library of Kotlin, which has no definition for any specific platform, but you have the same thing for the test. And the nice thing is for your Android module, you can have anything which is as you're used to in your Android module. You can have a specific the Kotlin coroutines module for the Android platform, right? And you can do the same thing for the test, and you can do the same thing for the iOS as well. So you can always define in your file what are all of my different dependencies for all the different modules, and it gets very structured and very simple. Let's see how that looks from Android Studio or from IntelliJ. If you're an Android developer, this is what you would have. Your Android app would have a Gradle file, and your Gradle file will have different implementations and all the different dependencies, but you just have to import your project as you would normally do with any other module. If your library happens to be deployed somewhere, you just have an AAR or a normal reference that you would have for any normal library that already exists out there. If you're on the iOS world, it gets a bit more complicated. The difference is, obviously, when multi-platform generates a artifact, it's something that Android already understands, because in the end, it's a Kotlin library generated for it. But on iOS, it gets a bit more tricky. So basically, you need to define from your multi-platform code and your iOS code in the multi-platform project, you need to be able to generate a framework file, which is what eventually your Xcode is going to understand, and how all the dependencies are going to be transient to that module. So you can define the different targets. So each module, each multi-platform library will end up being one framework file. And you have a very big function that will try to package that code for you and put it. You don't have to read all this. This just comes with the plugin already. So it will embed it for you. You don't have to worry about it. But this is already the first step towards how difficult it is, if I am an iOS developer, to start using all this thing. Well, it gets better. You have to have a different configuration in your Xcode project. You will have to define different scripts that will package that multi-platform project and then generate the framework file for you. You have to make sure you have your framework is defined in your search pods. You need to make sure you have different configurations for the bytecode, for the bit code. Then you make sure that your binary is already embedded. There's a lot of things that we'll have to do. Luckily for us, some very smart people have decided you can have a plugin that does all that for you. So at least, on that sense, all this packaging that you saw before, there's already a library that does all that game for you. But in the end, it's what we said before, right? It's not as welcoming if you're an iOS developer to start using it, but there are already solutions in place, and we can look at it. That was weird. All right, so let's start using the library. And in that sense, when you try to define how is my library going to look, what do I want to achieve with this multi-platform project, you can see it as, well, I want to start narrowing my business logic. I want to share, let's say, a network client, right? iOS app and iOS app, they all have network code. Well, let's try to start with something simple. Let's just define a network library that we can both use with both platforms. That would be like a very simple step. You can also go a step further, and you can say, well, I really want that both my iOS and the iOS app, my iOS and Android app, both have the same architecture vision, let's say. So we're going to try to follow, let's say, a model view presenter architecture for iOS and Android. You can achieve that too if you want. But importantly is, you have to keep it simple, right? If you have the reference of Kiss, love this group, love the outfits. Basically, it's just make it simple, start with something that works for you and for your team, and then if you're convinced by it, then try to move a step forward. But don't try to just build everything from the first day, because then it's going to be really hard for everybody. So let's start with a very simple and very lame example, so you understand what I'm saying. We're going to define a library that has common Android and iOS source sets. In each of those modules, we're going to define, in the common, we're going to expect a simple variable is going to call platform name. And that is what we expect that is going to be defined in each one of the modules. If you go to Android, the actual implementation of that variable is going to return Android shared photos. That means that whenever someone calls platform name from an Android world, this is the value that we want to see. On iOS, we're going to define the same, but it's going to be called iOS shared photos. Same idea. When we will call this from iOS, this is the value that we want to receive. So let's see how it looks from an Android world. From a activity, this is a normal Android activity. We can simply import the reference to platform name. There's nothing else that we need to do. Just call the function or variable with the same name you've defined in the multi-platform library. You can use it, and it's very simple. On iOS, that's the tricky part. This platform KT, that is in your multi-platform library, you define your Kotlin file. In iOS, when you import shared, and shared, that is the framework name that you've defined in your packaging options for the multi-platform library, it creates a platform KT, and KT is the suffix that it will add, the framework adds on their own. So you know that this is actually a Kotlin file, and here you're just calling platform name, which is a Kotlin function, from your Swift controller class. So that would be the only difference that you would see compared to your Android world, for example, where you just import the library, and that would be it. And then if you run this, obviously it's a beautiful example. It works. You have to trust me. That's how it is. That would be a very simple idea, right? It's a very simple function, returns the value, and then that's it. Let's make it a bit more complicated. Now we're going to try to have, and that was the library that we created. We're going to define a library that calls Google API to get all your photos from your device, or calls Instagram to get all the photos from Instagram from one user. It makes sense to separate that into one single library, because in the end it's the same code. You just need to return the values and the list of photos, and that will be it. So we're going to see how we can define something like that. There is a few plugins that we need to use, a few libraries, that make our life easier to be able to communicate between both worlds. Serialization is the first plugin. That's a simple multi-format serialization library that you can use in your multi-platform projects. And then Ktor, which is a server backend and client, front-end and backend client, that allows to define your server. Imagine like a simple Spring or any of the sort, right? We just want to be able to read things from a backend and then send them back to your client. And it has libraries for iOS, for Android, and also for your backend. And one step more, and this is where things get a bit more complicated, you can define that your library has their own threading mechanism. You can say that I want to make sure that I can launch things that happen on the library that are already asynchronous, so the clients don't have to worry about the synchronicity of the sort. So we can define something called application dispatcher. Is anyone familiar with coroutines? Yes? Good. Can you explain that? No. The idea is you have, imagine it's a simple asynchronous library that allows you to launch things, launch tasks in an asynchronous manner. Let's just leave it simple for that. We can say that for iOS and for Android, both of those threading mechanisms are going to be different, right? So in Android, we're going to use main dispatchers from coroutines, and it will look something like this. And on the iOS world, you can use the NSQ dispatcher. So you are using both iOS and Android mechanisms to deal with synchronicity, but you're defining how it's going to run from the multi-platform project. And hopefully you will get something like this, right? Both platforms will have their own photos. So let's take a look how it looks like. One way to go about it is to say, well, because I want all the logic to be on the library, we're going to define a repository that's going to return all the photos. And all we want to do is, from my native iOS and Android code, call this repository and just try to fetch all the photos that we have. All this code here is going to be living in the library, in the multi-platform library in the common module. Here we're just defining the HTTP client. This is part of the Ktor library. You just have a mapper to make sure that when you read an endpoint, you are able to pass whatever information comes from the endpoint into an actual class, an entity that you understand. And this is the nice part. You're going to have a function that you call, you passing a token, and it's going to return everything that comes from this endpoint. And when the repository wants to execute this call, you just have this global scope applied. This is part of the coroutines library, just to make sure for you that this asynchronicity is gonna happen. You launch all this work to be done in the main thread, in the background thread, and then the return, this callback is gonna be happening in the main thread. Does this make sense? Did you fall asleep already? Sometimes. Okay, cool. But basically, you have to trust that this is basically the network code being executed in the library and ensuring that everything is important happens on the background thread, and the callback with the result happens on the main thread. If you want to use this from the Android world, you just have to define your repository, get an instance to it, and just call the function that loads the data, and that will be it. Everything that happens inside the repository is defined in the library, and this is just the Android client and the front end that just calls it and runs it. From the iOS, it's a bit more complicated, and it's a nice thing to see. If you remember, this repository has a collaborator, which is an API. In Kotlin, you can just define it and make sure that it's instantiated and initialized inside the constructor. From iOS, it wouldn't work like that. So you have to provide all the dependencies. But once this is done, it will be the same thing. You can define the type alias, so in the closure, it's necessary to read when you call the function. And you have a function, request your photos, call the repository, and when you return, you just have to return the call. This is the ugly thing that you have to do to make sure that the Kotlin world and Swift world understand each other. But essentially, once you've done that little snippet of code so it gets better, this is how it would get. You get your photos from the repository, and you just save on the controller. At this point, everything is happening here is always happening in the library, and the other part is just the native part to make it look. And then the result will be something like this, right? All this part that we've seen, you just saw the photos, and then like a simple approach to it. You can go a step further as well, as we said before, and you can have a shared database. You can have a library that it's making sure that all the code that we saw before, you can, for example, persist all those photos in the actual native world, but all the definition happens in the library. There's a library called SQLDelite that allows you to do just that. It's a bit tricky to configure, but the idea is you're going to define all the different transactors in the library, and then there's an actual implementation that works on the native iOS and the native Android world. From Swift, you just have your own native SQLite driver, so for each platform, there are different drivers. These are the ones that you configure it for iOS, and this is how you would configure it for Android. This is what happens in any of those models that we saw on the library. And when we want to use it, it's something as simple as this. Imagine we have a repository, and what we want to do is we're going to get the token that we saw in the function earlier that has this the Instagram token. You can just call it from your database. You get the token, and all this execute as one that you see over there. It's just a function from SQLDelite. So it's just if you start using it, you'll see very simply. But essentially, this is something that also only happens in the library module, and then both projects that use it are going to understand what to do. Let's take it a step further, and let's start with something more interesting. Let's start with your presentation layer. What if we could define all those logics and all this presentation logic in the library, and then we need to make sure that both iOS and Android have to make the implementation for each of them. This is from the Kotlin Conf app. So JetBrains released an app for their annual conference, and it's a multi-platform project, so it's a very good example for you to see how this works in a real-world app. But basically, you have a presenter, And that presenter has an idea that how can they launch things asynchronous. This is the coroutine dispatcher that we saw before. This essentially is want to make sure that everything that happens in that presenter can be handled asynchronous for those platforms. And we have a presenter that you tell him, I want you to load the photos, and then the presenter, in a very normal MVP approach, you have a view, you tell the view that is loading, you load the data from the repository, and then you just tell the view, these are all my photos, please go and show them. So this is something that will be defined in the common module for the library. So this is where the presenter goes. In the shared code, in your library, you can define the actual view interface. So you would have a view interface in the shared module, and then you would have in your Android app, you would implement that view interface, and in your iOS world, in your controller, you will also implement the same interface. This is how it looks, a very simple example, loading, show photos, and show error. So what you want to do is when in the activity you implement it, the actual implementation of what show loading means in the Android world is just to set the visibility of a spinner to true. From iOS, the implementation will be start animating the loading spinner. As you saw, those functions are defined in the library, and this is just what you have to implement in your native code. There's a tricky approach that you have to do, and it comes to testing. So how do we test all the code that we've been defining in this beautiful library that it's magic and it works perfectly? How do we test it? For things that are, anything that is synchronous code, you can test it in your library. Very simple unit test. You parse the data, you place a date, and you make sure that the result is what you expect. This you could define in your multi-platform library. You can run the test in the library, and it would work. So basically, everything that is inside the common test folder, as long as there is no coroutines or nothing that is only available for different platforms, some platforms is going to work. Because even with coroutines has a function called run blocking that as of today is not implemented for all platforms. So for example, JavaScript does not have run blocking, so you have to fake it somehow, and we'll see how. And iOS has the same issue. So we have, again, you have to expect a function called platform run blocking that for Android is going to be a run blocking using the actual coroutine implementation. But if you want to use the one, the one from iOS is deleted, but well, we can see it if you check the example of this app, the port spiral protector, you will see the actual implementation for this. But essentially, you have to fake how those things happen in the Android, in the multi-platform world, so you can see it. And the test will look like this. You want to make sure that when this presenter loads all the Instagram photos, then you can for sure assert that the indicator has been asserted. These things that you exist, this common test that has asynchronous code, has a benefit that if you run the Android main source set for your library, you can use the actual implementation that works. And that is OK for your Android world, right? If you're just trying to use the library from the Android perspective, it's very simple to do these tests. But obviously, if you're the iOS developer and you have to run these tests, opening IntelliJ and make sure that those tests execute, you don't see your Xcode in front of you. It's a very different scenario. So that's when it can get a bit tricky. But for conclusions, they should not be at the bottom. As of now, you can't debug these Kotlin codes in Xcode, so you can't just fire up Xcode and see and put breakpoints. But we'll come back to that in a minute. There are good practices that you will have to follow, and this is not just for a multi-platform world, but also for any other world, let's say. There are instances of classes that when you move them from the library world to the native world are not going to run on the same way. So as a best practice, you always want to use immutable code. There are types in Swift or in Objective-C that can be different in Kotlin. And it might happen that when you run a struct in iOS, or you expect a struct in iOS, it's not the same constructor in Android. So it might be that some variables are different. So you're going to have to, if that happens, have to have a single a patch for it. But essentially, the most difficult thing is to keep everyone engaged. So when we were developing the library, for me, it was great. For all the iOS guys, it was great. We live in the same world. We just run IntelliJ, and everything is great. But you also have to put some empathy and understand that from an iOS perspective, it's not as simple for you to now fire up a new IDE and start learning Kotlin and start learning how these things would work in my world. And the truth is that the experience working for an iOS developer is not as good as the experience for an Android developer. But then a few months back, TouchLab is a company in New York. Is there an agency with really smart people, and Square, also a lot of really smart people. They start working together, trying to make this multi-platform model a bit better. And they work in understanding how can we make the experience better. And they launched two things that are really, really interesting. And one thing would be the native support for Kotlin native, and that would be the Xcode sync. Both things in particular allow you to have to debug Kotlin code from Xcode. You can add breakpoints, and allows you to feel much better about your multi-platform library. They're not as easy to configure, so there's a 10, 12-minute video on the page of the plugin where Kevin Galligan shows how to install it and how to make it sure that it works. It does work. I've had it and I've seen it, and it does work well. So again, it's not as simple as just what we're used to nowadays, but it's still a very good approach that allows you to, in this sense, debug code, which is something that we do on a daily basis. And some references, there's 4 apps that if you're interested, you should take a look. One will be the Kotlin Conf app from JetBrains that is also being revamped for this year. There is the Droid New York app, which is something that TouchLab worked on, and that is also a multi-platform project that has iOS, Android, and then a library for share with a lot of things. And then there's 2 more examples. The one that with the code that you've seen today is the Share Photos library, where it just has a very simple approach that you saw. And then the post-parallel protector also have a lot of things with a multi-platform library, and both works. And then in terms of talks, there was 2 talks last year in Kotlin Conf. There's a couple more this year as well. And there's another talk about the K-Tour as a project, which is very interesting as well. And that's it for me. I think it was very quick. But if you have any questions that you didn't fall asleep, I would love to answer. Yeah. That's better.
One question. Are you using this approach in a production application, or is it only a proof of concept?
No, the library that runs the code for writing the photos, we have it in a production app, yes. There's nothing experimental about, if you have a very narrow approach and you don't do things that are very, as long as you're not passing objects between instances of the library and your own native code and so on, you make a simple approach, it's as any Kotlin code that you could write today. So that is safe. And on the iOS world is also safe. Yeah.
Okay, thank you.
Yep.
You mentioned it's the same Kotlin code, so can you use reflection in Kotlin on iOS?
Same.
So reflection works fine on iOS?
Yeah.
All right, cool.
But if it doesn't work, don't blame me. There was someone there, I think.
How did you manage the iOS developers in your company to start working on Kotlin? How did you convince them?
Yeah. We put them on a chair, get with the stick. No, it's like any new framework that you would like to use in the team, right? You have to have a conversation, and you have to sell them the idea of, well, if you have, say you have a team of 4 iOS and 4 Android. Now, all of a sudden, you don't have to work on the same thing twice. Just one set of views is going to be working on it, and that's a benefit for everybody. You can develop faster because you can add more features in a faster way. You can make people happy because there's only one source of truth. It's like, oh, did you change the endpoint? Oh shit, I need to update the iOS app with a new endpoint or the Android app with a new endpoint. It's about showing that that you care about their opinion and making sure that everybody understands that there is a benefit of it. It might be that it doesn't work. You can have someone that says in the iOS team, well, I just don't want to learn Kotlin. And then you have to deal with that situation as a team per team basis. But there is a benefit that is clear, and it makes it easier to work on the long term. But obviously, as anything that if you have to say to them, let's move to a reactive pattern, how do you have the conversation? You need to tell them, wait, is this a benefit or is it not a benefit? No? It's more like I think it's a discussion per team. But in the end, I think there's a big benefit. It's a great benefit in the amount of time that you save, especially, and then making sure that there's only one place where your code is defined in terms of the business logic. The rest, you have time to play with animations and making it pretty. I'll give you my card. You need to talk to someone, I'll talk to you. All right. Thanks a lot for coming. Thanks for not falling asleep. I'm online. You have my Twitter handle and my email. If you try something and have some questions that you want to talk about it, I'll be here today and I'll be here tomorrow. And if you have any questions, just reach out. Thank you.